Artificial intelligence goes for beginner by knowledge and information. In this video we are discussing about image classification, part 2. Another important aspect of image classification is its ethical implications. As with any technology, image classification can be used for both good and bad purposes, and it is important to consider the ethical implications of its use. Some of the ethical concerns surrounding image classification include: 1. Bias. Image classification models can be biased, reflecting the biases in the training data used to develop them. This can result in unfair and discriminatory decisions, particularly if the models are used in areas such as criminal justice or hiring. 2. Privacy. Image classification can be used to identify individuals, which can raise concerns about privacy. For example, facial recognition technology can be used for surveillance purposes, leading to concerns about government overreach and potential abuse. 3. Misuse. Image classification can also be used for malicious purposes, such as deepfake technology that can be used to create fake images or videos for propaganda or disinformation campaigns. 4. Accuracy. While image classification models have become very accurate, they can still make mistakes. These mistakes can have serious consequences if they are used to make decisions about people's lives, such as in criminal justice or hiring. 5. Transparency. The inner workings of image classification models can be complex and difficult to understand, which can make it challenging to assess their accuracy and potential biases. In order to address these ethical concerns, there are several approaches that can be taken. One. Diverse and representative training data. One of the main causes of bias in image classification models is the lack of diversity in the training data used to develop them. Developers should strive to use diverse and representative training data to ensure that their models are as unbiased as possible. 2. Ethical review processes. Developers should implement ethical review processes for their image classification models to ensure that they are being used for appropriate purposes and do not have unintended consequences. This can include involving diverse stakeholders in the development process, including experts in ethics and privacy. 3. Transparency and explainability. Image classification models should be designed to be as transparent and explainable as possible. This can include providing detailed documentation on how the model works, including its training data and potential biases, and ensuring that decisions made by the model can be explained to end users. 4. Strict data access controls. To prevent misuse, data access controls should be implemented to ensure that image classification models are only used for their intended purposes and by authorized users. 5. Ongoing monitoring and evaluation. Image classification models should be continuously monitored and evaluated to ensure that they are performing as intended and are not having unintended consequences. This can include regular audits and updates to the model to address any issues that arise. In addition to ethical concerns, there are also practical considerations when it comes to implementing image classification technology. Some of these considerations include: 1. Availability of training data. Image classification models require large amounts of training data to achieve high levels of accuracy. In some cases, obtaining and labeling this data can be time-consuming and expensive. 2. Hardware requirements. Image classification models can be computationally intensive and require specialized hardware, such as GPUs, to achieve reasonable training times. 3. Model selection. There are many different types of image classification models available, each with its own strengths and weaknesses. Choosing the right model for a particular application can be challenging, and often requires expertise in machine learning. 4. Integration with existing systems. Integrating image classification technology with existing systems, such as e-commerce platforms or security systems, can be complex and require significant development effort. 5. Interpretability. As previously mentioned, the inner workings of image classification models can be complex and difficult to understand. This can make it challenging to interpret their decisions and identify potential biases. When it comes to the practical application of image classification, there are many different use cases across a wide range of industries. Some examples include: 1. Healthcare. Image classification can be used to help diagnose medical conditions by analyzing medical images such as X-rays or MRI scans. This can help healthcare providers make faster and more accurate diagnoses, improving patient outcomes. 2. Agriculture. Image classification can be used to monitor crop health and identify pests or diseases, allowing farmers to take preventative measures before yield is impacted. 3. Retail. Image classification can be used to analyze customer behavior and preferences, allowing retailers to optimize their product offerings and marketing strategies. 4. Security. Image classification can be used for facial recognition and other security applications, allowing for more accurate identification of individuals and improved security in public spaces. 5. Manufacturing. Image classification can be used to monitor production processes and identify defects, improving quality control and reducing waste. 6. Environmental monitoring. Image classification can be used to monitor changes in the environment, such as deforestation or melting ice caps, allowing scientists to better understand and respond to environmental challenges. One area where image classification is currently seeing significant growth and innovation is in the field of autonomous vehicles. Autonomous vehicles rely on a variety of sensors and technologies to navigate and make decisions, and image classification is an important part of this ecosystem. For example, image classification can be used to identify pedestrians, traffic signals, and other vehicles on the road, allowing autonomous vehicles to make more informed decisions and navigate safely. In next video, we will discuss about image classification part 3. Another area where image classification is seeing growth is in the field of social media and content moderation. Thanks for watching. Please like, share and subscribe.